This is Linrad on the medium waves. I will now make a long recording, and that's just press S. And before doing that I have to give Linrad the focus and then S. And I have a big partition on one of the hard disks on this machine, which is L:, and I name the file simply MW for medium waves. And now you can see the mouse is probably not very visible, but here in the upper half of the screen and the lower part of that there is the spectrum, and in the upper right corner of the spectrum there is a blinking S, meaning recording is now going on, and the time is 17:11 Greenwich Mean Time, or UTC perhaps, I don't know. And approximately, because I don't care so much about setting the clock correct on the computers. And now I'll just wait. I stop the video recording here, but I leave Linrad running and recording. Now it's 9 o'clock in the morning local time, or 7:53 UTC, as you can see on the waterfalls, and the recording has been running for, is it 15 hours or something? I forgot when I switched it on. So I press S to stop the blinking S, well, that we have here. S, and exit from Linrad with escape. To look what happened on the hard disk, I can start the defraggler. And look at the right disk here. And this recording fills a little bit more than 25%. If I tell this defraggler to analyze, I press analyze here, you can see it paints all the blocks red, and you can see one file is in the block. The only file on this partition is this file that I have saved now overnight, and I click it here, and you can see it is mw.raw, 4 fragments, and the size is 372 gigabytes, 0.3 terabytes. And to run a defragmentation on this would take more or less forever, and it wouldn't give any advantage because these fragments are ordered in time properly. And I don't know why writing comes in fragments like this. But there is no reason to worry about it. I made a copy of the file to another partition which is on the solid state disk I have in this system. That took about 1 hour, which means playing the file from the mechanical hard disk should take about 1 hour in Linrad, and that is to display the overnight recording, which spans about 13 hours. And probably it will be twice as fast or so on the solid state disk. We will see. This is the contents of adfile.txt, a text file that Linrad will use to find what recordings to play. And I have placed 4 recordings here. The one on the mechanical drive using parameters named MW1. And then from the solid state drive using the same parameters. And then the third line is also the solid state drive, but another set of parameters. And the fourth line is yet another set of parameters to use with the solid state drive. And I just save this in the Linrad directory, as you can see, Linrad adfile.txt. Now I can start Linrad and then simply press 1. And I want to run in AM mode, that is F. And I don't want to repeat. And here we are. This is now the recording playing. I want to rearrange the screen first, because I want the main waterfall to take as much space as possible. So I close the S meter, move this thing here. And there is no frequency window because the frequency is already as it is. It's in the recording. So this can be this big. And a big waterfall. Like that. And now I will look at the processing parameters a little bit. X, P. The bandwidth is 200 Hertz. I reduced that to 100 because I want the waterfall to run a little bit slower. First forward FFT version is 4, but I can make things run faster by allocating more threads to run in parallel, like this. And then I want the entire medium wave on the display. So I click here and say I want the frequency range 0 up to, let's say, 2 megahertz. And Linrad finds out I cannot get quite as much, but this is what I can get. And I want a different color scale, let's say 0.5 here, and allow Linrad to find the 0 point by right-clicking the box in the lower right corner of the waterfall, where it's now number 20, and right-click there, and Linrad decides 4 would be reasonable. So here is the waterfall, and if I just leave it running like this, it will take nearly 13 hours. And that's quite a long time. So I press F3 to do fast processing. Now it's like this. And I would like to see the whole recording on the screen, so I need a much slower waterfall. So I can put, let's say, 2000 here. And it has to be a multiple of 9, because I have 9 in the corner down here, the lower right corner of the main spectrum. So that's a first average. And then the waterfall lines sums up such averages. And you can see it runs now much slower, while the time scale grows many more minutes per centimeter. I got 6 minutes for about 1 centimeter. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have perhaps 3 hours on the screen, and I want 12 hours or something. 4 times more, that would be 8,000. I put 9,000 here, or I put the maximum I have. I made the box contain maximum 4 digits. Now the waterfall is really slow, as you can see. I press T, and from that we can see that the CPU load is about 10% and 25% on the most loaded thread. This is defined by the speed by which the hard disk can be read. I press X and then B to go back to the same thing, and then F3 and T to see. Now you can see the speed is much faster because some data from the hard disk is cached somehow. But this will not last very long. The cache has a limited size. I guess there is data from the hard disk in RAM somehow. There is a lot of RAM in this machine, but not really compared to the size of the file. So you can see 77%, that's the load of the most loaded thread, and total it's 29 or 30% of the total capacity of the computer. And I leave it running a little bit longer to see, to get the next time stamp on the recording. I can press Z, and then you can see that the speed isn't very high anymore, because we are not cached anymore. The average speed would have gone down pretty slowly because Linrad accumulates the speed since last pressing of the Z or since program start. So I press X and then 3, and I select to do exactly the same thing, but now from the solid state disk by pressing 1. And then F3 and T. And you can see 83%. The system doesn't know that this is a copy of the other file, so I expect it to stay at this high rate for a long time. So it's more fun to play with big files on the solid state disk, and presumably one could arrange several disks in parallel. But for Linrad in the current state, it wouldn't help much because we are at 79% CPU load. I could set parameters to make processing a bit faster, but not very much. That means I could select an easier window than the sine to power 3, which is used now. And I'm just waiting to see the next time stamp to get some idea about how fast this runs. And so this is 6 o'clock in the evening, 6:40 local time. And the sun is setting, but it is not down yet. And you can see we got half an hour on the screen already. So I'll go and have a cup of coffee and we'll come back when this is finished. Here is the waterfall from the entire night. This took 19 minutes from the solid state disk, and it would take about an hour from the hard disk, the mechanical one. So now, what is interesting, I'm not a DXer, so I don't really know, but I can note, for example, I don't know if the mouse is not well visible, but I move it around. We have here and here stations signing off at about 23.09. So I might want to look at that. That means press F. It was 23.09. Yes, F. And that must be while Linrad is running. So I press X and B and then F. I can set the start time to, let's say, 22.50.0 and the stop time to 23.10.0. And now the averaging is nearly 10,000, but I'm only 20 minutes rather than 26 hours, so I make this much smaller. Let's say 250. And then I press F3 to make it run fast. And here we can see, probably not so surprising, that the event of interest, that means signing off, happened at 23.00. And we can see changes on many stations. Something happens to the program. Some just continue past the hour. So this is top of the hour in DXer language. I can look a bit closer to it, but I would like to have Linrad repeat this time interval. So I exit and exit again, and now press 3. And here I press 2 to run Linrad from the solid state disk M:, but with a new set of parameters. So 2, enter. And I want the AM mode, that's F of course. Run repeat recording endlessly, yes. So here we are. Now the parameters are new, so I have to rearrange the screen a little bit. Let's see. This thing. Close the S meter. And the baseband graph here. Oops, that was just... And I don't want the waterfall of the main spectrum as big anymore. Now something has gone wrong in the playback. So X and back. while I'm rearranging the screens. Something like this, maybe a little bit more of the spectrum here. And I want to play this moment around 11:23. So I press F. And now select the time from, let's say, 22.58 .0 until 23.1.20. And I want to run the screen faster because we now cover a small segment in time. Let's say 50. And then I have a quick look by pressing F3. And I can see I'm running too fast. Let's make it 100. And I want to change the color scale. 0.5 here. And I right click on the 0 point box here. And now run the screen fast again with F3. So I see here is the frequency of a station signing off. And I run fast again. And I don't understand a thing of this, but this station will stop transmitting in about 1.5 minutes. So a quick pressing F3.
Vážení posluchači, vysílání Českého rozhlasu Plus nyní na středních vlnách končí. Naladit si nás můžete opět zítra v 16 hodin. Naše vysílání ale pokračuje v digitálních sítích a na internetu na adrese plus.rozhlas.cz. Posluchače v Praze a okolí současně upozorňujeme, že ráno a odpoledne přebírá naše vysílání také Český rozhlas Regina, a to na frekvenci 92,6 FM.
And there it disappeared. And I can then, of course, check other things. I run it again fast, F3. And I think it's clear what the idea is. I can take another station here. And of course, if you want to know what is going on the band during this period of time, we can click on them, all of the stations. And I want more bandwidth to get a nicer match to the bandwidth of this station. It speaks English, so I can understand what is being said. So I can run the baseband waterfall much faster, let's say 10 here. And I can click on a station in the baseband. Let's say this one is playing some kind of music. And then that station comes in the passband. So, looking for something up here. So this should be rather obvious what I'm doing. I could be interested in other things. So I go away to the parameter change menu and increase the number of threads. I don't remember why I did not put that high already. And I want this one maybe 100. First mixer bandwidth reduction in powers of 2 is now 4. 2 to power 4 is 16. So it means that the baseband has 1/16 of the 2 megahertz bandwidth. I increase that from 4 to 8, means a factor of 256 on the 2 megahertz, which is, what is it, 10 kilohertz? Should be enough for AM. It says 7.8 kilohertz. The thinking help. I will change now baseband storage time from 2 seconds, which means that the best resolution that could be obtained is half a hertz. I change this to 200, which means I can apply very long transforms in the baseband. And since I changed the FFT1 parameters, the scale has changed, so I click on the upper frequency scale to get this apply thing, and then I say I want from 0 to 2 megahertz, and then I click on apply here to get the entire medium wave band. And I select in the middle of the night by pressing F, and let's start at say 23.0.0 and run until 04.0.0. So now it's night time, and I will look for American stations, so I click on maybe 1030, and then I click again on 1030 here, and now with the very large transforms the noise floor goes down, so I have to increase the gain of decrease the 0 point of the baseband color scale. I can try 0 for example, yes. And here we can see there is a carrier on 1030, and for all I know it is probably an American station. I put minus 10 dB here, so we can see it. in the noise. I reduced the averaging of the waterfall, put 1 here, and now it runs faster, but the signal to noise is not quite as good. I can improve the resolution a bit, like that, and then we can see there are actually at least 2 carriers close to 1030. Maybe I expand a little bit more, then I have to put the 0 point lower and minus 20 perhaps. So here we have, most probably, I turn down the volume, I don't want to listen to this. So we have a couple of carriers. I could use the S meter to measure what is the signal level here. I will show in detail a little bit later. I'll just try another frequency, let's say 1020, should be around here. Uh, 1020 here. I have to wait for a little while. And I'll press F3 to run this fast. So there are obviously several stations, and I can right-click on the baseband waterfall, and the further away I move the mouse, the faster it runs. Where are we? Well, this is going too slowly, so it's no fun. So I click on 10, 10, 10. It's here. Somewhere. And this is in the middle of a strong station, so it's useless. 1 megahertz. And here we have American stations also. So there are a lot of them, and I could measure the signal levels. I will show how to calibrate that. I simply go to normal reception. It's set up as before, that means press F. I make one more experiment with this. I don't see any reason why it shouldn't work anymore. Here we are. And here is the medium waves. And I need to know what is the signal level here, so I connect the signal generator to the antenna input. This is minus 70 dBm on 1 megahertz. I have to make room for the S meter somewhere. And I click here on the S, upper right corner, it's just now placed, to open the S meter graph, and I make it a decent window. And like that. And then I click on the S in the lower left corner until it shows dBm, and select the signal here, and we can see it doesn't show what it should. It should show minus 70, but it shows something else, minus 43 or so. So I had to add 27, one or the other sign, I don't remember. It was the rate. Now it shows minus 70 dBm. So I have to take notes to transfer this to the recording. I haven't changed the hardware settings as far as I can recall, but in case I actually have changed, I will have to change them back to get the same calibration when playing from the recording. So it is 27 for the S meter, and then X and P. I was using 200 Hertz, and I remember I changed the recording to use 100 Hertz, so I changed that here. And then the sign window matters, so that is now to power 3. And the first FFT amplitude must be the same, it's 4000. And the other parameters don't affect the S meter. So I click on the signal again. It moved since I changed the FFT bandwidth. And we can see it didn't change much, just a little. I can read here. It says minus 71.9. So it should be, I think, 25.1 here. Now it shows minus 70, just like the signal generator. Now I'm back on the recording, and I reserve some place for the S meter and click on the S and make the S meter window of a suitable size like that, and then make it show dBm. And put 25.1, I think I arrived at here. And then look at the parameters X, P, and these are the same. Very good. So I can click on the typical medium wave stations. Here is one. And there is a yellow curve and a white curve. The yellow curve is RMS power. That's what I'm interested in. The white is peak power, which could be interesting in SSB mode. But for AM I want the average power. And we can see this is a typical medium wave in the early evening, and it's minus 70 dBm from this not very good antenna. And if I try to center it better in the... Here is the carrier. Now it's centered in the filter, and that makes no difference. I might want to look at the carrier power and not the power of carrier plus sidebands. I do that by reducing the filter bandwidth down to something like this. And then, of course, to see anything, I need to have the carrier on the right frequency. And I don't want to average in the baseband, so I put 1 here so we can see quicker. and I see I have lost the carrier. It's, I don't know, maybe it should be on 1008. Here we are. And now the carrier is in the filter, and I have to make the S-meter graph run faster to see it in a reasonable time. And you can see the carrier is close to minus 70 dB also, because it has the amount of energy in the sidebands is not so big. So now I change the time. That means press F and go to around midnight. That means 23.0.0 to, let's say, 4.0.0. Enter. And have a look at the US stations. Could be about here. And I have to wait for the carriers to appear. And this looks like a good carrier, this one. Then I have to wait a little bit. And of course it's weak, so I have to change the 0 point for the S-meter graph. And to see better what I'm doing, I can expand the baseband. That's the outwards arrow on the left side. And to make sure that I'm really measuring the carrier and not so much of the noise around it, I can make the filter a little bit narrower. Like that. And then press F3 to run this faster. So here we can see the station from the US. There is some QSB on it, but it's between 130 and minus 125 to minus 140 dBm. And there is another station. It had a QSB peak here. If I go on 1 megahertz here, look at this carrier. I think I will see better by having some averaging in the baseband spectrum. Let's make it 10. So it's possible to see that the frequency is right. And this one is minus 130. If you have DXer friends in other countries, you could compare this kind of carrier amplitudes and find out which station is which and so on. And maybe a higher frequency is better. I haven't really tried that. There should perhaps be some. This looks like a gap. Go down 2 kilohertz. Oops. And now it has to be 170. 1470. And this is presumably an American carrier. What the other stuff is, I don't know. Maybe some computer interference or something. And if I look at lower frequencies, I don't know where the American band starts, but maybe here is a gap. Doesn't look promising. Here. Well, obviously I don't know much about the frequency planning on the medium waves and where Europeans and the Americans are located. But 640 is a frequency with many strong signals. And one of them is not particularly frequency stable, as is obvious here. And these are strong signals relatively. Minus 110 or something. So I try to make the window, I make the frequency span in the baseband much larger, like this, so I can step the frequency quicker. I just want to see at 649 if that is a strong signal. 649. No. So maybe after all that was a US station, because the European is this one at 648. Presumably. Well, I just wanted to show a little bit how to use Linrad on recordings. And before skipping this, I will do another thing. That's X and B. Oops. It will remember the timing. So it's still playing in the midnight. I have to do X and X to get back to the menu here, and then go back to the processing of the file. I have changed AD file to go to that point by pressing 1 because it saves some key pressing. Now it starts at, was it 17 something, and I look at 1030. Here, and expand the baseband again to 15. And this is where we had the American stations. And now I tell Linrad to run fast. I make this averaging the biggest and press F3. And I have to make this run very slowly. And this will take some time. So I will go and have another cup of coffee. So we can see from the baseband waterfall how the sun is setting over the United States and maybe Canada or somewhere else, I don't know, and making the ionosphere thinner so the medium wave signals can reach here. I'm about 100 kilometers west from Stockholm. We can see stations 20 hertz below and maybe 40 hertz below the nominal frequency 1030, and many stations within just a few hertz. One is drifting quite a lot. That's characteristic. I think anyone almost anywhere in the world who can listen on this frequency at this time will see if it's the same signal or not, just based on how the frequency changes with time. There is also one about 7 to 8 hertz above nominal frequency, which moves in a characteristic fashion. It is possible to look a little bit in details on this. To do that, I just press X after making sure I have focus on Linrad, X, and then parameters, and I leave the first FFT unchanged, but reduce the baseband bandwidth from 8 to, let's say, 11. That is a factor of 8 more resolution. And again, look for 1030. .0 here, or maybe 1030.1. That's where the strongest signal was located. Now it is 8 times slower, so I go from 100 to 10 here to get 10 to get a similar speed on the waterfall. And I don't have to have the spectrum expanded, so I put it back like this, and then press F3 to collect the long time spectrum again. And I can make the S meter run much slower. Like this. So we can see how this signal is awaking. And of course I have to expand. It says now 12. That is the FFT size, 2 to power 12. And I have to go up to 15 again. And you see now limit is FFT1 storage time, and I need at least a factor of 4 more of that. X, and things take time now. Or maybe even don't work 100%. So I press instead escape and restart, and 1 to get back, and X and P. And first FFT storage time, it's 8. I make it, let's say, 200 seconds. That could be too much. Yes. So I make it where is it? Storage time. Let's make it 60 seconds then. 2 megahertz is a fairly wide bandwidth, so I cannot store for an infinite time. So 20. The baseband storage time, it is harmless because the sampling speed is so low in the baseband. And 1030. Here. And now I try to expand again the baseband. And this is how far I can come today, because today Linrad is still a 32-bit executable under Microsoft Windows. So this sets the limit for the resolution I can have in the baseband. And I forgot one more thing that I could look at. That is X, P, and then enter, enter. I can put a more beautiful filter here. I make it 8. That's a Gaussian filter. That will make the resolution better on the carriers. Like this. And then F3. And I have to make the brightness higher. So I put minus 30 here. And here we are. And the noise floor is lower because of the higher resolution, so I move the baseband spectrum. And it's clear here that the shape of the spectral lines is much more beautiful. And it's also clear that the color is a little bit too bright, so I make this minus 25 instead. Because the noise floor is going to increase later in the night. So I leave this running for a while and then come back. And since I didn't have memory to increase the resolution as much as I had thought, the waterfall is running much too fast. So I changed that from 10 to, let's say, 50 to get it 5 times slower. And then I will repeat and come back when it has shown a reasonably long waterfall. And we can see here there are stations that start to disappear maybe 4-5 o'clock or something in the morning, and even earlier. Presumably they are east of my location. I don't know the frequency planning in Asia or maybe Russia or so, but it's clear that those that disappear seem to be less accurate in frequency than those who are still strong at close to 1030. I have pressed Shift F3 to stop the processing at this point, so I press Shift F3 again and then F3 to run fast to see how the recording ends. I didn't go much longer than this. I don't remember exactly the time when I stopped it. Oh, it was here. Now it is repeating, and that is not going to be any interesting. To get an idea about what are the lowest signal levels that can be copied, I have selected one of the fairly weak signals with normal settings from Linrad, and you can hear a little bit of it. This is minus 100 dBm, and that is 30 to 40 dB more than we had from the US stations. Can try another. Here is a fairly weak one. And there is definitely a voice there in the background, but difficult to hear. This is minus 100 dBm. Let's see, here is some a little bit stronger. And at minus 90, copy is easy. So the limit is somewhere. That is at the noise floor of this point in time, 1714. And the noise is going to be a little bit higher later in the night. So something like 30 or 40 dB is missing for the US stations to be possible. But there are many of them, so detecting anything from here is probably not possible, even with good antennas.